morning. So in class on Thursday, we were working with optimization problems with our quadratic functions. And the last word problem that we looked at got a little confusing, mostly because of the variables that I decided to use to represent the unknowns in our problem. Okay, so what I wanted to do was just to record a video going over a similar problem that'll hopefully make the process a little bit clearer to you so that it's not so confusing. All right, so here's our problem. It's almost identical to what we looked at on Thursday. It says, among all pairs of numbers whose difference is 12, find the pair with the minimum product. What is the minimum product? So one of the things that you have to realize with any of these optimization problems, whether it's a minimum product or a maximum area, is that we're really dealing with two functions. The first is going to be our quadratic function because, we know we're in the quadratic section. That's what we're going to minimize or maximize. But the second function is always some sort of constraint, something that restricts the quadratic that we're looking for in a particular way. All right, so we're going to go ahead and distinguish between those two things, the constraint and the quadratic, as we work through this problem. All right, so first, among all pairs of numbers, right, so we have pairs of numbers, and as I mentioned, you can use any two letters you want to represent those pairs, except for X, because X is where we ran into trouble on Thursday. So I'm going to define my pair of numbers. I'm going to say let M and N represent the pair of numbers. Okay? So there's two random numbers out there, and I'm going to use M and N to represent those two numbers. And the other information they give us about those numbers is that their difference is 12. So when I subtract those two from each other, N minus M, I'm going to get 12. Right? This is our first function. We have two variables that are related to each other, right, with an equal sign. So it's an equation, a function. And it's not a quadratic because none of these are squared. So this is actually our constraint, and we'll go ahead and work with this over here. So we've got N minus M equals 12. This is actually a linear function, okay? If we were to graph it, it would look like a line. We'll just draw a little sketch down here. But instead of having X and Y as our axes, we would have N and M. And our line would look something like this. Okay, the intercept is 12. It has a slope of positive 1. And every point on this line, every ordered pair, if you were to take the difference of that pair, you would get 12. So this would be something like the point 0, 12. 12 minus 0 is 12. Or negative 12 and 0. 0 minus negative 12 is 12. Or you could have something like, let's say 20 and 32, right? Or 25 and a half and 37 and a half. Okay, all of these pairs, any pair that's on this line has a difference of 12. What we're trying to do in this problem is to find the one pair, the one spot on this line that when you take that ordered pair and multiply it together, it gives you the minimum product. Okay, because you can multiply all of these together. 0 times 12 is 0. Negative 12 times 0 is 0. 20 times 32 is 640. Right, so we're getting bigger. But is there anything smaller than 0? And that's what we're trying to find out with this question. Okay. Normally when we deal with a linear equation, we have it as y equals something. Well, in this case, we have n, so what we're going to do is add m to both sides, and that's going to give us n equals m plus 12. And this is the constraint that we're going to use. Okay, so hopefully you're with me so far. Now, let's go back up to the problem. We need to find the pair, which means we need to identify m and n, such that we find the minimum product. Okay, so there's something else we're looking for, the product. And I'm going to say, let's let our product be P. So let P be the product of my pair of numbers of m and n, which is really just a long-winded way of saying P equals m times n. Right? Product is multiplication. We've already identified our constraint, so this is actually where our quadratic is going to come from. Okay, so let's go ahead and slide that up here. We've got P equals m times n. Now, it doesn't look like a quadratic yet, and that's because we have three variables. We have the product, m, and n. We need to cut that down. We need to get rid of one of those. And the way we're going to do that is by using our constraint. We know that n, is actually m plus 12. So I'm going to take out my n, and I'm going to replace it with m plus 12. Okay? So that brings us to P equals m times m plus 12. And if I go ahead and distribute that, suddenly my quadratic appears. All right, and I have P equals m squared plus 12m. Now I have a product, a quadratic, that I can minimize. Right? This is a positive quadratic, which means it's going to be an upward-facing parabola, and it will have a minimum. And that minimum is going to occur at the vertex. Right? So with this whole minimum product, we are looking for a vertex. Okay? So now we know that we have a formula we can use to find the vertex of a parabola. All right, I'm going to go ahead and give myself a little bit of extra room up here. So far, when we've dealt with the formula for finding a vertex, we've always said that the x-coordinate equals negative b over 2a. Well, we've always used x because on our axes, we have x and y. All right, and we find the x-coordinate, the horizontal coordinate, using this formula, negative b over 2a. Well, on this quadratic, m is our independent variable. So that is our horizontal axis, and p is the dependent variable. Okay, and this again is why we have two different functions. We can see the function with n and m, and then we have a function with p and m. All right, so when we are finding a vertex on this axis, it's not going to be x equals negative b over 2a. It's going to be our independent variable, m. M equals negative b over 2a. Okay? In our quadratic here, a equals 1, b equals 12. Okay, so I can plug those in. M equals negative 12 over 2 times 1, which equals negative 12 over 2, which equals negative 6. Okay, there is one of my numbers. Okay, from here, there's a number of ways we can proceed. So we know that m is equal to negative 6. We have an m over here as well, right? So let's get rid of these. We know that m is equal to negative 6. That's only one part. We're looking for three pieces. We need the pair of numbers, n and m, and we need p. So let's start by finding n. N equals m plus 12. So if I substitute in, now that I know m, n equals negative 6 plus 12, n equals 6. Okay, and that would be this point right here. Negative 6 positive 6, and that gives me the point negative 6, 6. Okay. So there's our pair of numbers. We can erase this again. So n equals 6, m equals negative 6. I also need to find the product. Okay, so I can come over to this equation, and I can say that p equals m is negative 6. So negative 6 squared plus 12 times negative 6. P equals negative 6 squared is 36. 12 times negative 6 is negative 72. And that leaves us with P is negative 36. Okay, so my product is negative 36. And that's the point on this graph. Okay, this is the point negative 6, negative 36 as the lowest possible point, the vertex, the minimum value on that quadratic. Okay, so even though, when we were looking at our ordered pair examples, like we had 0 and 12, or 0 and negative 12, those products were 0, but this product that comes from a pair of numbers of 6 and negative 6 is actually even smaller than that, right? This is our final answer. Pair of numbers, product. Okay, so a lot of times in these cases, you're looking for 3 things. You're looking for dimensions or a pair of numbers, and then you're looking for an overall area or an overall product. So hopefully that makes the process a little bit clearer for you. We will look at a problem like this for a warm-up tomorrow in class, but hopefully this is enough to get you through the homework and to help you study for your quiz. Okay. Thank you.